Okay, this video is going to talk you through the chi-squared test, which is an inferential statistical test that we learned about within the learning approach. You can see the formula on the screen now. This is also given to you, don't forget, on the first couple of pages of your exam paper, as is the formula for calculating the degrees of freedom, which I will explain to you later in this video. Don't forget that learning about chi-squared actually links it to issues and debates. It's an example of how psychology can be a science within methodology, because we're testing the significance of our results by using a chi-squared test. Now, a chi-squared test would be used if we're doing a test of difference between two situations and if we're using nominal data. So we're using it with an independence measures design where the data is nominal. So we're looking at frequencies. So, for example, the number of times an event occurs in each categories. The categories are obviously independent of each other. A test of difference is needed, and there must be at least 20 observed scores. So that means that you have to have had 20 participants. You can't be expecting less than 5 expected scores in any category, and that will make sense when you see the columns in a second. Now, what's really important to remember about the chi-squared test is that it actually tests the null hypothesis. So it tests your point that there will be no significant difference in your results. In the example that we're going to look at, the null is that there's no association between finding reality TV entertaining whether you're male or female. And under the null, the expected frequency shown that equal amounts of men and women find reality TV entertaining and equal amounts do not. And the reason we're saying that is because if there was no significant difference, then we would expect the equal amounts between men and women to be the same. So, for example, on the screen here, we've got the results that have been collected there between men and women and whether they find reality TV entertaining and whether they don't find reality TV entertaining. And we've got the totals, as you can see, in the bolded numbers in the middle just here. Now, the expected frequencies, which are the numbers at the bottom in brackets, so these ones here, these are calculated using this formula down here. So we've done the row total times the column total divided by the overall total in order to be able to calculate the expected values. And let me just reiterate, the expected values are what we would expect if our null hypothesis was correct, so if there was no difference between them. Step 2 is using the chi-squared formula, which is stated just here in the middle, and as I mentioned, is actually given to you at the front of your exam paper. My top tip to all of my students with this is to make sure that you understand it, because then it doesn't become a memory game in the exam trying to remember what steps to follow. If you can understand this formula, then you can tackle it on the spot. So let's have a look. This here obviously just means chi-squared, and it means to work out the chi-squared, we use this here, which is sigma, and that means sum of. So we do the sum of. In brackets, in maths, we always do the brackets first. So we do the observed value, take away the expected value, and we square that. We then divide that by the expected value again, and it's the sum of that which will give us the chi-squared total in the end. For each pair of the observed and the expected frequencies, all we have to do is take those away, divide it by the expected value, and then we will get our chi-squared. Don't forget, though, that you have to do this for each pair of answers that you've got. So let's have a look at how this works in practice then. So carrying on with the idea of finding reality TV entertaining or not, depending on whether you're man or woman. If we do that exact formula, so this one at the top here, so we're doing the observed value, take away the expected value squared, divided it by the expected value, and what you can see down here is I've tried to replicate the exact table for you, so you can see that for here, I've done it here, for here, it's here, and I've done it for every single one of my possible values, so I've done it 4 times for here, and here is here, to get all of my values which are bolded. Now the next step is the sigma part of the formula, which means sum of. So I'm going to take all of these values that I calculated, so there were 4 values, I'm going to add them all together, and that actually gives me my chi-squared value at the bottom. Once we've done this, in order to be able to find out and to make a strict comparison, we need to do one more thing, and chi-squared is the only inferential statistic that requires you to do this, and it's what is abbreviated as DF, and it actually means degrees of freedom. Now you're given this in your exam, so it's at the front with the rest of the formulas, and it tells you that to calculate the degrees of freedom, you do the number of rows minus 1 multiplied by the number of columns minus 1. So in this situation, we've got 2 minus 1 times 2 minus 1, which is obviously 1 times 1, which is 1. And let me just reiterate, this is because I have 2 rows, and this is because I have 2 columns. So row 1, row 2, column 1, column 2. Now I've done all that, I need to use all of this into the critical table in order to be able to get my value. So if we just have a little look here, we've got the probability that it's down to chance is less than 0.05, which we know is the standard that psychologists use. I know that my calculated degrees of freedom was 1, so if I follow those across, I can see here that my critical value is 3.84. Now, because my observed value, which is the value that I worked out, that was my chi-squared value, and the critical value here was the one I just got from the critical values table, which is 3.84. Don't forget the little tip I taught you, that if there is an R in the name of the statistical test, then the observed value, so our value, has to be greater, hence the R, than the critical value. So let's just have a little look at this. Our observed value, which is this one here, needs to be bigger than our critical value, which is this one here, for our results to be significant, and in this case it is. Now, how do you write this up? Because they often ask you to do this in an exam, they often ask you to write this up. We would say our results are significant, suggesting there is an association between gender and whether they find reality TV interesting or not. Because our observed value, and we always state the number in brackets, is greater than the critical value, and we state the number in brackets, at the level of P is less than 0.05 for a two-tailed hypothesis where the degrees of freedom were 1. So it's a lot of information to put in, but you must make sure that you remember it all. Because our results were significant, we reject the null hypothesis, and we must make sure that we put that in there as well.